Welcome back to PPB. In this video, we are going to talk about first normalization form. So let's just dive right in. 1NF or the first normalization form. Nowadays, 1NF is considered to be part of the formal definition for relations in okay.
Relational
This is
database.
part of the definition, formal definition. Okay, this is part of formal definition, for relations in
Relational database.
for relations in
Relational database.
okay. Fine. And this ensures that relations are in a simple but structured form. Okay, this ensures the relations are in simple but structured form. That when we navigate through this, okay, when we talk about this in the future, we will get an idea why do we say this. Okay, so first of all, let's talk about the special characteristics or the key characteristics of a relation in the first normalization form. Let's talk about that first. So let's talk about the key characteristics. Okay. The key characteristics we can have two main key characteristics. The first one is eliminating the relations within relations. Eliminating relations within relations. What do I mean by this? Think for a minute. Eliminating relations within relations. Well, what I'm trying to say is if you have multi-valued attributes or composite attributes inside a relation, they may create nested relations inside. Those types of attributes. Which types of attributes? Composite and multi-valued attributes. Sometimes there can be combinations of this. Okay. Combination of composite and multi-valued can be there. We don't want these attributes because these attributes belong to a separate relation. All right. So we are saying that we can't have attributes which are relations themselves. This is the first one that we are talking. So we can't have these types of attribute. No composite attributes, no multivalued attributes. Second one, atomicity of attributes. Atomicity of attributes. This is a huge thing in 1NF. If you have this one, if you have multiple relations inside a relation, you can easily catch that. Okay. The second one is what we have to really implement. That is very important. So I will talk that very deeply. Okay, talk about that very deeply. So atomicity means any value, okay, any value of an attribute of a tuple has to be an atomic value. An atomic value. You know what atom means in Greek, right? Atomos. Atomos means in Greek, it means indivisible. Okay. Atomic means indivisible. So what do I mean by that? It should be a single indivisible value. Indivisible value. Okay. Let's say you have a tuple. And you have some value x and you have value y and you have value z. And in another attribute, you have a, comma b, comma c. Now, this is a multi-valued attribute that we can see. But according to the 1NF conditions, a relation can't have multi-valued attributes. So you will have to do something to get relief of them. So this can be discussed as, see, we have domains for attribute, right? The data values allowed for attributes. That's what we call domain, right? So these domains should allow only atomic value, atomic value for its attribute, for its attribute. So this will finally ensure that value of an attribute of a tuple is drawn from a simple domain. Okay, what is a simple domain? Well, a domain that only allows atomic values. Okay, right. So this is the key characteristics. Now let's go to the practical rule. Okay, first of all, we will talk about key characteristics that you can see in a relation uh, in a normalization form. And then we will talk about the practical rule that we can apply. And then we will finally talk about the formal definition. Then we will do some example questions to study normalization form. Not only for 1NF, for 2NF, 3NF, BCNF, 4NF, 5NF, everything. So that we will be completely clear about what's happening. All right. So, practical rule. Practical rule. We have to eliminate repeating. That is the practical rule. Eliminating repeating group. The repeating group means only the multi-valued attributes and composite attributes. Okay. So we have to identify and separate the attributes into distinct tables. First of all, identify and separate, identify and separate sets of related attributes, sets of related attributes into distinct tables, into distinct tables. So after you are separating these sets of related attributes into distinct tables, you should make sure these tables or relations, we know that tables are called as relations, right? So these relations must have a primary key. We have to ensure these relations have a primary key. Relations have a primary key. Have primary key. That's it. So this is the practical rule. This is the practical rule. So what is the formal definition? What is the formal definition that you should write in the exams? I will give you a common formal definition, but you can rewrite this in a way, but make sure to use the keywords. All right. The first thing that you must include is all attributes in the relations have values drawn from simple domains. All attributes in the relations, all attributes in the relations should have values drawn from simple domain, or you can say atomic domain. That's your wish. Second one, each value of an attribute in a tuple should be atomic. Each value of attribute of a tuple should be atomic. Should be atomic. Right? Or you can say indivisible or single, whatever the word that you find easy for you, you can use that. So these are the practical rule and formal definition for 1NF. So now we come to the $1,000,000 question. How can we achieve 1NF? Steps to achieve 1NF. Steps to achieve 1NF. Well, the first part is identifying the repeating groups. We have to identify the repeating groups. That's very important. Identify repeating groups. Once you identify the repeating groups, create new relations. Create new relations. Last but not least, assign primary keys. Sounds simple, yes? Yeah. Okay, this doesn't look so bad. It's easy. We can how can we identify the repeating groups? We have to identify the multi-valued attributes, which will be very easy. If we have eyes, we can actually find out what are multi-valued attributes, and also we will find out what are the composite attributes, and also the combination of these two attributes. That is what we have to do first. Then we will move them to distinct tables. We'll move them to distinct tables, and then what can we do? We can assign primary keys for them. Well, that depends. Sometimes the primary keys can be single or simple primary keys, or sometimes it can be composite primary keys that depend on the relations that you're making. All right. Now we are going into example. Now let's go into example. Let's say we have something like department ID. Okay, this is the department relation. This is the department relation that has department ID, department name, department contact number, and finally department location. Listen to this, location. And they are saying department locations is a multi-valued attribute. This is a multi-valued attribute. So how can we make this a single, I mean, a single valued attribute or a atomic valued attribute, and then make this relation into first normalization form? Well, the first approach that I use is breaking down into tables by using the functional dependencies. See, we know department ID functionally determines department name. We also know that functionally determines the department contact. Okay, but department location can be determined by department ID. But the thing is, there can be multiple values for the same department, even though the department contact can be the same for different department locations. The department locations is going to be the trouble here. So what I'm going to do is, I'm going to pick that out. Okay, I'm going to pick that out. Let's say we have department ID 1 and department name IT. Let's say the contact number is 1111. Let's say the locations are London and Los Angeles. And let's say there is a department ID 2 and the department name was finance. And the department contact is 2222. And there are some other places like Colombo, New Delhi, and some other place like where else do we have? Let's say Berlin. I know. Okay. So if we have this, we have to break this, right? This is not in first normalization form. This is in unnormalized form, zero in it. Why? There are multivariate attributes, repeating groups. So we can't have this in first normalization form. So what you will do is, you will break this. Department relation can only have department ID, department ID, department name, and department contact. Now this is great. Now we have actually made a relation. We have decomposed the relation into smaller relation that is having the attributes department ID, department name, and department contact. Now I will create another relation, department locations. Department locations. Well, this will have department ID, comma, department locations. And these both will be the primary key here. Okay. This will be a composite primary key. But the thing is, I won't have multi-valued attributes. I will break them down into single values. Like for example, I'm writing that relational, some example relational instance. I will give it to you. Let's say this is what we have, right? So I will have 1 London, 1 Los Angeles. Let's say this is LA. Can't write it again and again. So the 2 will have Colombo. 2 will also have New Delhi. two will also have Berlin. I know these two are required to uniquely identify a tuple in this relation. But see, this is in first normalization form, and this is also in first normalization form. So we have succeeded in making the relation into one NF. Okay, let's check, is the lossless join property possible? Yes, it is. Yes, it is. Original data will be stored back. Okay, and then the second one was FDs. Well, FDs are properly maintained. There are no new attributes that are introduced. Okay, so this is perfect. This is perfect. All right. Now let's do another example. Before I go to another example, this can also be done like this. Okay, we can have the same relation, department, and we don't have to break this relation into two. Just we can keep it like department ID, department name. This is another approach, department name, and we can have department contact, and we can also have department locations in the same table, same relation. But the thing is, instead of department locations in the same single cell, there will be in different cell. They will be in different cell. So London. So this will be a composite primary key directly. That will there will be London, there will be LA, there will be Colombo, etc., etc. But the thing is, there will be redundancy. The department name and department contact will repeat again and again in the same relation. We don't want that. Even though this approach is correct for finding the one NF, we don't usually use this for one main reason. There will be redundancy. Okay, we don't like that. We don't like redundancy. So the first approach is better. But is this one correct? Yes, it is. Why? There are no repeating groups of attributes. So this is correct. All right. Even though this is correct, since it is not efficient, we normally say this is not good. We normally say this is not good. Now I have to teach you. I already taught you that it won't also allow composite attributes, and I told that these create nested nested relations inside a relation, right? I told you about composite attributes. Now I will give you an example for that. Let's say we have something like student table. Yeah, let's say we have student table, and in the student table, let's say we have stud ID, we have stud ID, and then stud name, and then we have stud name, and we have course ID also in that. I know this is not a good schema, but I have to teach you. So course name, and also let's say we have hobbies plural, hobbies plural, hobbies. So it's a multivalent attribute. This specific example, okay, in this specific example, the relation looks like, okay, when the relation is given to you, the relation looks like this. Okay, we have stud ID, okay, and then we have stud name, and under course, okay, this is how the table looks like. Student, course, we have course ID. This is actually a composite attribute, yeah. Course is a composite attribute that is with course ID and course name and all. And then we have hobbies. Okay, so we have hobbies in students. So how can I write that? Let's say this is in specific column. Let's say hobbies. Okay, so this is how the column actually looks like. All right, this is how the column actually looks like. The relation, the columns of the relation actually looks like this. The attributes look like this. Okay, so we can definitely say this is not in one NF. Why? Well, we have this composite attribute. This is a composite attribute, and this is also composite attribute. Okay, this is also composite attribute, and this one is multivalued attribute. This one is multivalued attribute. So first of all, we have to remove these nested relations. First of all, we have to remove these nested relations. And then we have to remove the multivalued attribute so that there will be no repeating groups of attribute. Then we can check whether the atomicity of the table is achieved. Okay, the atomicity of relation is achieved. They are saying they are using the student ID and course ID to identify the whole relation. Okay, so the problem first, we have to take care of composite attribute student. So we can simply break this into student ID and student name. So we don't need the student. So we can say the relation student has stud ID. Okay, we have the stud ID and the stud name. Cool. Now we have to break down this also. We'll get course ID. Okay, we'll have course ID and course name. That's not an issue. And those two composite attributes will be broken down. Now we have hobbies, finally. Now, okay, now we can clearly see they are in single value. This is a single valued attribute. This is a single valued attribute. This is a single valued attribute. This is also a single valued attribute. So that's done. We have finished that. That's fine. That's fine. Now we have hobbies. Okay. So as we normally do, we can also break this down. Okay. How can we break this down? We can have the student ID. Okay. We can have the student ID and hobbies in a specific column. Okay, we can have the student ID and hobbies in this, not a specific column, in a specific relation. Okay, we can have them in the specific relation. So I will break this down. Okay, I will decompose this as student relation. There I will have stud ID, stud name, course ID, course name. We know hobbies only depend on stud ID, so that doesn't matter. So we will just have stud hobby, another relation. Where we'll have stud ID and hobbies. But in this case, instead of writing multiple hobbies, we will write down the hobbies one by one. Okay, we will write down the hobbies one by one. So in this case, it will be like for student ID 1, we will have multiple hobbies. We will have gardening, we will have reading, we will have gaming, etc. etc. But in this case, it will look like one gardening, one gaming, one reading, like that. Okay, so here also we have achieved the atomicity. But still, this is not the reliable way to give the relation. Why? We have student ID and course ID. Course name only depends on course ID and student name only depends on student ID. So this is what we are going to talk in 2NF. Okay, we are going to talk about partial functional dependency and how to eliminate it in the next video. So this is for 1NF. For 1NF, you just have to maintain atomicity of the attributes. That's the main goal. Okay, in that process, you will also eliminate the multi-valued attributes as well as the composite attributes. But it all boils down to one thing, one and only thing: make the attributes atomic. Okay, only single valued attributes are allowed. Keep that in mind.
Thank you for watching this detailed guide on first normal form. Found this video useful? Let us know in the comments below. Don't forget to like, subscribe, and share with your friends to support the channel. Hit the bell icon to get notified about the next video in the normalization series. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.